The cosine rule for unknown sides can be rearranged to find unknown angles if all three sides of the triangle are known. Okay, so I've just drawn a diagram here, so just draw your attention to that. There's triangle ABC. None of the angles are given. They're not known. Okay, so we can't do anything at the moment. However, we do know all three sides. Now, if all three sides are given, we can rearrange the cosine rule to make cos of A the subject. Okay, so let's do that. So we'll start off with A squared. We're going to subtract B squared and C squared we're going to move them over and it becomes a subtraction. So we're going to subtract B squared and C squared from A squared minus C squared is equal to negative 2BC multiplied by cos of A. Now I'm going to put the negative 2BC in brackets. It's going to make it a bit easier to explain what I'm about to do next. Next thing we're going to do is we're going to divide both sides by negative 2BC. Negative 2BC is multiplying the cos of A. I want cos of A to be the subject. In fact, I want A to be the subject eventually. So we're going to move negative 2BC over the other side via division because it's the opposite of multiplication. Okay, so A squared minus B squared minus C squared over negative 2BC is equal to cos of A. Just switch both sides around. Okay, so cos of A is equal to A squared minus B squared minus C squared over negative 2BC. And if you just want to make angle A the subject of the formula, therefore A is equal to inverse cos. Okay, so if you move cos over to the other side, so I want angle A to be the subject. All right. Inverse cos of A squared minus B squared minus C squared over negative 2BC. Okay. The formula can be presented in a slightly different way. You might have seen the formula with a positive 2BC, but then it'll be B squared plus C squared minus A squared. Okay. Either formula is fine. So I'm just going to use this one. Let's have a look at some examples. So find the size of the largest angle in the triangle shown. So the first thing to note is where is the largest angle. So I'll just put some labels there on the vertices. Okay, so we have triangle ABC. The largest angle will be opposite the largest side. Okay, now I could have used any letters really, so I've just kept it simple here just for the purpose of this demonstration. Right, we have three known sides, but an unknown angle. Okay, so let's use the cosine rule for angles. Okay, you can either just use the formula direct if it's given to you in a formula sheet, or you can rearrange the cosine rule, or if you just happen to know it, you can just use it directly. Okay, so cos of A is equal to A squared minus B squared minus C squared over negative 2BC. A good way to remember this one is just think it's all negative signs and it's just A, B, C up the top. Okay, and every letter is used twice. So A and A, well, letter A is used twice, even though one's uppercase, one's lowercase. The letter B is used twice. The letter C is used twice. And it's all negative signs. So there's one way you could remember that. Okay, so we want A to be the subject though. Okay, and we do have values for A, B, and C. Okay, so what we might do is I might label the triangle. So there's side A, there's side B, and there's side C. And it doesn't really matter B and C where they are. It's A that's in fact most important. Okay, so cos of A is equal to, now A squared is going to be 4 squared minus B squared, so it's minus 2 squared minus 3 squared. Okay, so that's our C over negative 2BC. So negative 2 times 2 times 3. Okay. Let's make A the subject of the formula. So A is equal to inverse cos. Okay, remember inverse cos, little negative 1. Okay, 4 squared minus 2 squared minus 3 squared over negative 2 times 3. Okay, and we'll answer this question to the nearest minute. Okay, so inverse cos, and we'll just type in the expression there. Okay, I tend to use a calculator as much as possible right at the very end. I like to plan out what I'm doing first. What am I going to type into my calculator is what I write down as part of my working out. okay, rather than just rushing to the calculator. Okay, I think we're happy with that. Okay, just comparing it. Yep, negative 2 times 2 times 3. Yep, and we have 104. It's 104 degrees and 29 minutes. Okay. Yep. Just making sure again. Yep. Rounding correctly. Yes, that's correct. So this is an obtuse angle triangle. All right, let's have a look at another example. And this one's an interesting example because it's not, you're not trying to find the size of an angle necessarily here. You're using the cosine rule to prove that a triangle, it's not possible to have a triangle with these dimensions. Okay. So let's see how this is going to work. Let's draw our triangle first. So let's say 1, 2, and 4. You might think, okay, well, why don't we do what we did in the last example? Let's see if we can find the size of the largest angle, which is opposite the largest side. Okay. So I might just label this triangle there. Okay. This is our A, that's our B, and that's our C. So let's see what's going to happen now. All right. So cos of A is equal to, okay, A squared minus B squared minus C squared over negative 2BC. Okay. Cos of A, let's substitute in the known values. Okay, so A is 4 squared minus, now B squared, 1 squared. C squared is 2 squared over negative 2 BC. Negative 2 times 1 times 2. And let's see what's going to happen now. A is equal to inverse cos of 4 squared minus 1 squared minus 2 squared over negative 2 times 1 times 2. Let's see what happens. Okay, so shift cos. Yep. It's because we want an angle, so a little negative 1 there. Okay, 4 squared minus 1 squared minus 2 squared over negative 2 times 1 times 2. Ooh, we get a math error. Doesn't work. Let's see why it doesn't work. Okay, so 4 squared minus 1 squared minus 2 squared, negative 2 times 1 times 2, okay, we get negative 2.75. Okay, so why is this? Okay, so inverse cos of negative 2.75. That's not possible. It's like the square root of a negative number. Your calculator tends not to like that. Okay, so therefore this triangle is not valid. Okay. No, it's not a valid triangle. All right, one more. Yep, there it is on the back. There we go. WXYZ is an irregular quadrilateral. Find the value of angle ZWX correct to the nearest degree. Okay. What do we need here? You can see here that there's probably two things needed. The angle that we want is this angle here. Okay, so let's call that, I'll just relabel it angle theta, even though it's got a W there. Let's just call it theta because just to highlight that it's in fact that's what we want. So in fact, to find a missing angle, okay, I could use the sine rule, but there's no other angles given, at least in this triangle, WXZ. However, if I did have side XZ, this side here, okay, so let's call that, that's a little y, so that's opposite, capital Y there. If I had this side here, XZ, side Y, I could then use the cosine rule for angles to then find angle theta. So let's do that. So we're going to have to apply the cosine rule, but in two different ways. Cosine rule for sides here, because what do we have? We have two sides, and we have an included angle, okay? No side angle pairs, so sine rule cannot be used here. All right, so I think that's really important. I know I've said that a few times, especially in previous videos. Very important to discern which of the rules do I use? Do I use sine rule or do I use cosine rule? Okay, in these non-right angle triangles. I either have a side angle pair, known side angle pair, or if not, I might have two sides with an included angle, or three known sides. Ooh, that's what we're trying to achieve here. So let's do that. Let's find y first. So y squared, okay, is equal to 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 55 degrees. Okay. Now I'm not going to round until the absolute very end, so I'm just going to write the full answer. Okay, so we have 8 squared plus 10 squared, okay, minus 2 times 8 times 10 times the cosine of 55. Okay, and I get 72.22777. Right. Equals 72.2277018. Y is equal to the square root of all that, 72.2277718. Okay, so I'll take the square root of that, and which equals 8.49. Yep. 8692263. Great. So now I have a value for y. Now we can use the cosine rule for angles to then find angle theta. Okay. So cos of theta, okay, is equal to y squared. We have a value for that already. Okay. Minus 7 squared minus 6 squared over negative 2bc. So 2 times 7 times 6. Okay. So I'm just going to use this part of the board here. Okay. So theta is equal to inverse cos. Now we know what y squared is. In fact, we're given the y squared here. We can in fact use this value directly. Okay, so that's going to be 72.2277718 minus 7 squared minus 6 squared over negative 2 times 7 times 6. Okay, and we're taking the inverse cos of that, and we'll just get our answer directly. Okay. That's to the nearest degree. So let's do that. Shift cos. Okay, open brackets. So 72. Okay, I'll just brighten that screen a little bit. Yep. So 72.2277718 minus 7 squared minus 6 squared over negative 2 times 7 times 6. Close brackets. Yep, and we get 81 degrees. And that's to the nearest degree.